Here is our isosceles triangle ABC with variables assigned to these unknown lengths. We notice that angle AEC and DEC are supplementary, so they have negative cosines. This suggests using law of cosines on triangles AEC and DEC and doing a substitution for these angle cosines. So for triangle AEC, we'll say that the square of this length AC 4x squared is 7 plus y squared minus 2y root 7 cosine AEC. And similarly with triangle DEC. We'll multiply this out and change the sign of this expression, replacing cosine DEC with the negative cosine of AEC. And we'll square the left-hand side of this equation. Now we'll add these two equations and solve for y squared. Looking for some other congruent angles, we have this angle up here, angle ECD, is the same as angle ECB, but of the larger triangle. So we'll use law of cosines on these two triangles, ECD and ECB. So y squared is 9x squared plus 7 minus 2 times 3x times root 7. That's 6x root 7 times the cosine of angle ECD. And we'll repeat this for the larger triangle. We've got a y squared here in this equation, so we can substitute for this expression in terms of x squared. And we'll copy this equation down below, replacing the cosine of angle ECB with ECD since they're the same angle. Again, we'd like to get rid of these cosine expressions, labeling these equations as 1 and 2. We can eliminate those terms by multiplying our first equation by 4 and the second equation by negative 3. Now we'll add these two and we'll solve for x. And we'll substitute this back in for our expression for y. So y is the square root of 11 halves. Let's redraw our triangle ABC with these lengths. We have a lot of triangles with congruent side lengths, so I think we can use same base, same height here. So this top triangle on the right, triangle CED, has the same area as the top triangle on the left, CEA, and these two triangles below segment AD also have the same area. That's BED and BEA. So adding these two triangles on the left gives us triangle CEB, which is half of the area of our big triangle ABC. Let's take a look at triangle CEB and its side lengths. Testing the square of BE and CE, that's 9 plus 7 or 16. This is the square of our third side, which means angle CEB is 90 degrees. So now we can find the area of triangle CEB. The area of triangle ABC then is 3 root 7. The problem asks this be written as m times the square root of n, which means m plus n is 10. If you'd like me to solve any other math contest problems, please leave them in the comments.